Problem 9 states a cannon fires a projectile as shown. The dashed line shows the trajectory in the absence of gravity. Points M, N, O, and P correspond to 1 second intervals. Using G equals 10 meters per second squared, the lengths X, Y, and Z are. So, drawing it out here, these are the lengths we're looking for, X, Y, and Z. We're looking for those. Now, this is a hard question. It's even kind of hard to understand exactly what's going on. So let's break it down real quick. This path right here, this linear path, it says represents the path if there was no acceleration due to gravity. So, if there is no acceleration due to gravity, we could figure out our vertical displacement by just saying d is equal to our constant velocity times our time. That's our basic formula, just rewritten v equals d over t to this. This is our formula for whenever we have no acceleration. Now, if we were to figure out our displacement with an acceleration, our vertical displacement, then what we'd do is we'd say d is equal to vit plus 1/2 at squared. Okay? Now, I'm going to put a negative in here just to prove a point, and for this particular problem, if our initial velocity vector in the y direction, we know it points vertical because our velocity is upwards and to the right, so if we're talking in the y direction, then it's going to be vertical, then our acceleration term is gravity, and it's going to be downwards, therefore it's going to be negative. Okay, so assuming up is positive, then what we can do is we can actually rewrite this formula as minus 1/2 gt squared, which I believe is something like one of your projectile motion formulas. So, if you notice, there's a certain similarity between these two. You got this guy, and you got this guy, and then this one just has this extra term in there. And I'll show you what you can do with that. So I'm going to zoom in to just this part of the problem and say, here's X, here's N, here's M. Okay? So, what's happening here? And let me make this a little more clear. And this is just a straight horizontal. Okay. So what's happening here is we have a couple different things going on. If this term right here would be the vertical displacement if there was no acceleration. So, what I'm going to say, that's it right there. Okay? This distance right there is this, v times t. Now, this term represents the displacement if there was an acceleration. And that's going to be this displacement right there. It goes up to there. Okay? So the difference between these two is this term right here. Okay? So this guy measures all the way up to here. This guy only measures up to here. So what happened is we must have subtracted something. Actually, let me make these vectors and make it a little bit more realistic. So what we can do with that is we can hopefully realize that this term right here represents this displacement down. If you take this Vt and subtract this 1/2 gt squared, you end up with the actual displacement right there. Okay? That's what you need to understand to be able to do this problem. Because they don't care about anything that's going on, really, and they don't give you a lot of information. They just want to know these weird, obscure terms, x, y, and z, which we can figure out is just going to be 1/2 gt squared. Okay? So, if you guys can understand that and figure out a way to come up with that on your own, then what you can do is just simply say, let me think. Oh, it's just 1/2 gt squared. They give us time of, so they're 1 second intervals, excuse me. So this is 1 second intervals between them. So n is at 1 second. This is t equals 2 seconds, and t equals 3 seconds. So for n, if t is equal to 1, then that term, this distance right here, x, is just going to be basically 1/2 10, our gravity, times 1 squared, which will just give us 5. Although it's going to be negative, actually, no, none of the answers are negative in here, so you don't have to worry about it. It's not very clear whether they want it to be negative or positive, but it looks like they're just looking for the actual values, so we're not going to be worried about any of the negatives in here. So at O, we have y, it's going to be 1/2 of 10 times 2 squared. So 2 squared is 4, divided by 5, we're just going to put 20. Okay, and then last one, nothing new here. Our z term is 1/2 10 times 3 squared, which is going to be 45. Okay, so remember those aren't actual any particular displacements, they just represent these x, y, and z terms. So the real trick is understanding your kinematics formulas really well and be able to sit there and realize the difference between a straight line path and solving for displacements with no acceleration and solving for displacements with an acceleration, looking at your kinematics formulas, recognizing this and this look kind of similar, just knowing your kinematics and doing your practice tests. So good luck, and that's the end of this problem. Of course, choice 1, 5, 20, and 45 is going to be your correct answer.